Number 88, a pulley of radius r and a moment of inertia, 2mr squared, is mounted on an axle with negligible friction. Block A with mass m and block B with a mass 3m are attached to a light string that passes over the pulley. Assuming that the string doesn't slip on the pulley, answer the following questions. And we have to express answers in terms of m, r, and fundamental constants. So for A, what is the acceleration of the two blocks? So the first thing we should do is a free body diagram. And we have a tension force going up. We'll call it tension force A. Since it's the lighter, the two masses, it's going to accelerate up in this direction. We have 3 mg over here, and its tension force we'll call tension force B. It's going to accelerate downward. So we need to sum up the forces, translational first, and then rotational. Let's do the translational first. So for each one, let's do A. So we have sigma F equals MA. And we have tension A up minus mg down equals MA. So we have tension A equals mg plus MA. And for mass B, we're going to have the summation of forces equal negative 3ma. Negative because this one is accelerating downward. The forces, we have tension force going up and 3mg going down equals negative 3ma. So TB, the tension force B, is going to equal 3mg minus 3ma. All right? So let's do rotational now. So we have sigma tau equals moment of inertia times angular acceleration. And again, since this thing is probably going to, the 3 mass is probably going to go downward, this pulley will rotate this direction, which is clockwise, which we, by definition, are calling it the negative direction. So we have to put a negative sign in front of the mass acceleration quantities. What we need to do is convert these rotational quantities into their translational variation. So let's see, let's add up the torque. So if we look at the torque, and if we were to say, okay, let's pretend like TB is not here, or that this 3 mass doesn't exist. What way would the first mass rotate the pulley? Well, it looks like it would rotate it counterclockwise, which would be a positive direction. All right, so then if we go back and say, okay, what would happen if this mass weren't here? What would happen with the pulley? Well, then it would rotate clockwise, which is a negative direction. All right. So the summation of the torque is going to be torque A, which we said was positive, minus torque B, which would be negative, equals negative moment of inertia times angular acceleration. Well, we know that torque is equal to force times distance from the center of a line connecting to the axis of rotation times sine theta. And we know since we're pulling this off at 90 degrees, the sine of 90 is going to be 1. So sine theta we can forget about. And what force do we have that's acting here? Well, the force is going to be the tension force. So we can get rid of this and replace it with tension force times R. All right. So we have tension force A times R minus tension force B times R equals negative I times angular acceleration. What we can do now is factor out the R. And the moment of inertia they gave us is 2mr squared. And acceleration, we have to get angular acceleration into linear terms, so that equals r times angular acceleration, or angular acceleration equals a over r. So we can substitute this in for our angular acceleration, and we'll do that over here. So since we have an r in the denominator here, it's going to cancel the square, and then we have an r on both sides. We could divide both sides by r, and we're left with Ta minus Tb equals negative 2ma. All right, so now what we could do is get Ta, which we said was this right here, and subtract Tb, which is this here. So let's do that. So we have mg plus ma minus, and it's minus the whole quantity, 3mg minus 3ma, and that's going to equal negative 2ma. Taking the 3mg and 3ma out of the parentheses, we're going to have mg plus ma minus 3mg plus 3ma equals negative 2ma. Putting any term that has the acceleration on the right side of the equal sign and keeping anything with the g on the left, we're going to have negative 2mg equals negative 6ma. Well, if we have a negative on each side, they become positive. We can divide both sides by mass, so the mass disappears. So if we solve for acceleration, we have acceleration equals 2/6 g, or g over 3. So for B, what's the tension force in the left section? So solving for that, we would need this equation here. Ta equals mg plus ma, mg plus m. Now acceleration we said was g over 3. So that's like saying mg plus 1/3 mg. So that's mg we can say is times 1, which is 3 over 3. So we're going to have 4/3 mg for the answer for B. For C, we have to use this equation right here. Tb equals 3mg minus 3ma. So we have to plug in g over 3 for A. That cancels the 3's. So Tb is going to be 3mg minus mg is going to be 2mg. And lastly, D, what's the angular acceleration? Well, we have that up here. Angular acceleration equals A over R. Our acceleration is g over 3 times R. That would be our angular acceleration.